morning, students. In today's class we shall study about explicit and implicit functions, and we shall also see how to differentiate such functions. So explicit functions and implicit functions. So far, whenever we have referred to any function, we have usually said that y is a function of x. We write it down as y is function of x. And we mean to say that y can be expressed in terms of x. For example, y is equal to x plus 1. So whenever y can be expressed in terms of x, that means y is a function of x. Such a function is said to be an explicit function. Let us take one more example. Let us take a function of x and y and write down the function as x cube plus y minus 3xy is equal to 0. So you can see here the polynomial equation given to us here. The equation can be rewritten as, taking y common here, y is minus x cube upon 1 minus 3x. So here you can see that y is expressed as a function of x, hence this function is an explicit function. Let us consider one more example here, a function of xy written as x cube plus y cube minus 3axy is equal to 0. Now you can see here powers of y are different, so y cannot be written as a function of x. So in this case, this function is said to be an implicit function. So explicit and implicit functions have both variables x and y. And here we shall always be considering y as the dependent variable, x as independent variable, as long as we are considered to do the other way around. Okay, so here, now since we know what exactly is an explicit function and an implicit function, we can identify them. So we are going to see how do we differentiate such functions. So for that, let me explain it by taking up questions from exercise 5.3. So we'll start with the first question. The first question is 2x plus 3y is equal to sin x. You can see both variables x and y, so you know this is either an explicit or an implicit function. You want to find out what exactly it is, then you can rewrite the equation as 3y is equal to sin x minus 2x, and hence y can be written as 1 upon 3 times sin x minus 2x, where it is very clear that y can be expressed as a function of x, hence this is an explicit function. So since this is an explicit function, we are going to differentiate both sides with respect to x. So derivative of left side with respect to x and the derivative of right side with respect to x. Now here when we are differentiating, we will have to remember all the previous cases. That means if we come across a composite function, use chain rule to differentiate it. If the need arises, we may be required to use the product rule or the quotient rule or other standard results of differentiation. So here differentiating the first term, we get 2. Differentiating the next term, 3 is a constant, so differentiating y, we get dy by dx. And on the right side, this is a standard sine function, so the derivative is cos x, and hence we are able to find out dy by dx, which is cos x minus 2 upon 3. So this way we are able to find out dy by dx. Now let's try out more questions from this exercise. So from exercise 5.3, let's try out the third question, which is ax plus by square is equal to cos y. So here there are again both variables x and y. This is either an explicit or an implicit function. To find out whether it is which of these functions, you can see here powers of y are different, so this has to be an implicit function. So once again we are going to differentiate both the sides with respect to x. So here first term, a is a constant, so a is multiplied by derivative of x, which is 1. Next, b is a constant multiplied by derivative of y square, so I'll write down like this. This is derivative of y square. Then on the right hand side, cos y is a standard function, but at the same time angle is not x, hence it's a composite function. See, the variable here is y, the variable here is x. If these two variables do not match, we can consider this as a composite function. So we are going to differentiate the cos function first and we get sin y. Then differentiating the angle, we get dy by dx. Likewise over here, differentiating y square, we get 2y. Again differentiating y, we get dy by dx, which is equal to minus sin y dy by dx. So taking the derivative terms on one side, 2by plus sin y dy by dx is minus a, and hence the derivative would be minus a upon 2by plus sin y. So next we will try question number 4. xy plus y square equal to tan x plus y. So differentiate both sides with respect to x. So I'll start with the right hand side first. Derivative of the tan function, this is standard trigonometric function, its derivative is sec square x. Then derivative of y is dy by dx. On the left side, y square, this we have seen in the previous question also. Derivative of y square is 2y dy by dx. Now coming to the derivative of xy, here it is product of x and y, so we are going to use product rule. So I'll write down the product rule first. X into derivative of y plus y into derivative of x. That's the product rule. Simplifying further, x dy by dx plus y, because derivative of x is 1, plus 2y dy by dx equal to sec square x plus dy by dx. So there are these terms with the derivatives. Let us bring all these terms to the left hand side. So we shall have x plus 2y. When this term is shifted here, we get minus dy by dx. So all derivative terms are on the left hand side. And let's take this term to the right hand side. This one is already on the right hand side. So sec square x minus y. And hence we are able to get the derivative as sec square x minus y upon x plus 2y minus 1. So next question is question number 6. It is x cube plus x square y plus xy square plus y cube is equal to 81. We have both the variables, so we know it is explicit or implicit function. Looking at the powers of y, because all powers are different, we know it is an implicit function. So differentiating left side, each term of the left hand side and differentiating the right side with respect to x. This derivative is simple, 3x square plus, over here we are going to use product rule because it is product of x square and y. So putting here the result in bracket, alright, writing down the derivative x square into dy by dx plus derivative of x, which is 2x into y. I put it in brackets to ensure that this is a derivative of the next term. Likewise, over here, again product rule, x y square. So, x into derivative of y square, which will be 2y dy by dx plus derivative of x into y square. Then next term, this is a composite function. So differentiating y cube, we get 3y square. Then differentiating the base, we have dy by dx. And on the right side, it's a constant. So derivative is 0. So now, where are the derivative terms? 1, 2 and 3 terms. So let's take dy by dx common. So x square plus 2xy plus 3y square dy by dx, and let's take all the other terms on the right hand side. So each term will be negative, so taking a minus sign common, minus 3x square plus 2xy plus y square. So finally we are able to find out here dy by dx, which is negative of the numerator upon x square plus 2xy plus 3y square. So this is a question where you have used number of rules. While differentiating this, you have used the concept of chain rule. While differentiating this term, we have used product rule. Differentiating this term, we have used product rule. This was a standard result. Here again, derivative of constant, standard result. So we have used here number of standard results and various methods to find out finally dy by dx. So next is question number 7. Sine square y plus cos xy is equal to pi. So here also you cannot express y in terms of x, hence this is an implicit function. So differentiating both sides with respect to x. So here I am writing down derivative of the first term on the left side plus derivative of the second term on the right side and in the left hand side, and derivative of the constant on the right hand side. So we know derivative of this constant is 0. Now coming to the left hand side, here look at this function. This is sine square, so it is a composite function. Angle is also not x. Variable with respect to which you are differentiating is not y, hence the variables are different, so we get to know this is a composite function. We can directly differentiate. Consider this as kind of x square function, so we know the derivative of x square function would be 2x, 2 into base. Now there is a sine function, so differentiate sine function, we get cos y. Then differentiate the angle, we get dy by dx. So the derivative of the first term is this. Move on to the next term. Here again, see here, it's a composite function, trigonometric ratio, and the angle is xy. So we'll first differentiate the trigonometric function, which gives us minus sine xy. Then to differentiate the angle here, this is the angle xy, we shall be using product rule. So let's write down one more step here. 2 sine y cos y, if you want, can be written as sine 2y. Okay, this is a standard result. 2 sine y cos y is sine 2y. Here it is minus sine xy, and derivative of this using product rule would be x dy by dx plus y is 0. So collecting the derivative terms, we have sine 2y minus x sine xy dy by dx, and then this sine xy multiplied by y is on the right hand side, so the sign will change. We have y sine xy. So this way we have obtained finally dy by dx, which is equal to y sine xy divided by sine 2y minus x sine xy. Okay, next question number 8. Sine square x plus cos square y is 1. Here, see, you can rewrite the equation as cos square y is 1 minus sine square x, and cos y is under root 1 minus sine square, which you can also write down as cos square x. So what will be y? Y will be cos inverse cos x. This way you can simplify. What I need to say is that you can write down y. Y can be expressed in terms of x. So this is an explicit function. Now to differentiate it, differentiating the left side with respect to x, so here we get 2 sine x. This is a composite function because power of the sine function is 2. So 2 sine x, then differentiating the sine function we get cos, and derivative of x is 1, plus this is again a composite function, so it will be 2 cos y. It's just like x square, so we have differentiated x square 2 into base, then differentiating the cos function, which gives us minus sine y, finally differentiating the angle, which is dy by dx. On the right side it is 0. So here we get this is sine 2x. Okay, this can be written as minus sine 2y, dy by dx is 0. So finally dy by dx can be written as sine 2x upon sine 2y. Now students, here you have to ensure that if the given equation is this, we are rewriting it like this, just to mention that y can be expressed in terms of x, so it is an explicit function. Here y will be equal to x only if this x belongs to the principal branch of the cos inverse function, and the principal branch of the cos inverse function is this. Alright, so if the angle belongs to principal branch, only then y is equal to x. In that case, you find out the derivative will be 1. So if y is equal to x, come back to the result obtained here. If y is equal to x, then this derivative will also become equal to 1. So here we have not directly written here, we need to know whether the angle belongs to the principal branch or not. Okay, so if you are rewriting this way, there should be no confusion that here derivative is 1 and here the derivative is not 1. The derivative can be 1 only when y is equal to x. Y will be equal to x only if x belongs to the principal branch of the cos inverse function. Okay, so with this we have finished questions from exercise 5.3 which were based on explicit and implicit functions.